Okay, before we go to the materials, you may wonder why we need to learn this section, why we need to have the index tables for database systems. So the main motivation is to find some desired information by values from the database in a very fast way. Because the database tables we have can be huge, right? We can have millions, even billions of records in the tables. If we plan to find some of the matching records or tuples matching our provided information, if you still remember before we have this selection, this operator, right? If we want to find some data tuples matching some attributes, we have to do a search to help us, right? Therefore, we need to have some data structures to help us do the search in a faster way. The time cost is very important for database tables. So to meet this motivation, we have to use indexing in this section. And we'll cover some common properties about indexes. We have some properties to be described for index tables. And based on these properties, we will introduce two different data structures to help us. The first one is called B plus tree. The second one is called hash tables. I think you have known about the trees in the data structure course, as well as tables, hash tables, in the data structure and discrete mathematics, as well as algorithm courses, right? So if so, you should know some basic information for trees and hash tables, hash functions. So it can provide you with some background knowledge for this section. Then what is the indexing? Indexing is a label pointer pointing to some items that satisfy some properties or some common properties. We see different indexing in the real world. Like if you open a textbook, we can find different indexing tables. At the front pages, we have a table of contents, this page, right? It provides the indexing actually. So providing some keywords or some topics, we can find the matching pages in the book. Given the topic, we can find a matching page, right? Similar for different topics or for different sections, we can go to the corresponding pages in the book. So the table of contents is an indexing table we can see in the real world. Beside the front pages, at the very end, we also have an index table for the keywords or phrases. Right? Given a keyword, we can find a page mentioning this keyword or defining the keyword. Right? This is also an index table. Given some desired information, we can find a pointer pointing to some pages of the book, right? So it's another index table we can see from the textbooks. Besides the indexing tables we can have in the textbooks, we can also find different index tables in a higher way, right? So personally, I don't like driving. However, I have been driving for many years. Before I studied in Chicago, and then I moved to Florida, and I have to drive a long way from Chicago to Florida. And generally, when I drive along the highway, when I was hungry, I have to search for or look for some restaurant, right? Normally, so if you have driven before, you should know that along the highway we have different boards. Boards can provide the information for different exits. It will mention in the next exit we will have some food, a restaurant available for the drivers, right? So we can go to the exit and also take a break at the restaurant and have some food. So this board is also an index table for the drivers because given the restaurant names, we can know which exit we can go to have this food. Right? It's a pointer pointing to a specific exit along the highway. Besides this, we can also have the index in the supermarket. So if you go to some supermarket like Target or Publix, you can have different sectors, right? Different sections. And above the sectors, we have some boards indicating some of the products we can find in these sectors. So this is also an index. So given the product name or some category of the product, we can find the sector we can go to look for these products. Right? It's also an index table we can find in the real world. So you can find a common property for these different index tables, the textbooks, the highway, the food exercise boards, as well as the boards in the supermarket. They all provide the people with a faster way to search for some desired product information as well as restaurant, right? So the function is to help us, help people to search for something. This is the motivation to have these index tables in the real world. I mentioned different kinds of index tables that we can create. I hope you can know the function of these index tables. Generally given a desired number, right? We want to find a location for the data tables matching these numbers. The generally given a desired number, right? As well as the index table. The question we are studying in the database system for induction is to build a function which can map these desired inputs, the numbers, to a specific entry in the index table. And via the pointer in the index table, we can locate the data table in our database systems. So this figure in this page provides an illustration of the index tables we plan to create. So we have one line here. Above the line, they are corresponding to these index tables. And below the line, they correspond to the tables in database systems. They are storing the data records. And these entries above the line denoting the index table, we have entries inside the index table. Squares below the line denoting the specific data records in our tables. And this triangle denoting a mapping function we plan to build, right? A mapping function we plan to build. Given any number we plan to search via some mappings or data structures, it can help us project this number to a corresponding entry in the index table. And via the pointer from this entry matching these inputs, we can locate the corresponding data tables in the tables. And we can identify these data tables matching our inputs in our database systems. So this is the search process. Given inputs, so via some mappings, we can find the matching entries in the index table very fast. So we can find the tuples from this index entry, right? And in this page, we will provide you with different index tables, which are either clustered or unclustered. The clustered and unclustered means the tuples we store in the real-world systems, they are either clustered or unclustered. For clustered index tables, for all the entries we are pointing to, they are sorted according to the search keys, right? And this pointer will point to the beginning to the end in a sequential manner. However, for this unclustered index, the pointer will point to the tuples that are mixed together in the direction, right? Okay, so this is about two different types of index tables we can create. So far, I hope you can follow me, right? So for the index, we are building this data structure above this line. We plan to have a very efficient data structure to help us, given any number, we can locate the corresponding entry matching this input number in the index table. This matching process should be very fast. After we do the matching, we can access the pointer, right? In other words, we can access the data tuples we're storing in our database systems. So the main focus in this section is on this part. How to build this triangle as well as how to build these index entries.